Now, this is a little demonstration of expanding double brackets. So we're going to think about what happens if I've got that shape there. And let's suppose that I know some lengths but not all of them. So let's say that I know that that little length there is 3. And let's say that I know that this little length here is 5. And let's say I don't know what this length is, so we'll call it x. And you can see from that that's a square, so this length is going to be the same. Now, if I was going to work out the area of that entire shape, we know that the area of a square or a rectangle is length times width. So I know the length of that entire side there is going to be x plus 3. And I know the length of that entire side there is going to be x plus 5. So what I'm doing is I'm multiplying x plus 3 by x plus 5, and then remembering that in algebra we like to take our times signs out so don't get confused with x's, we can just write it like this. Now the trick in doing this is to realise that the area of that entire big shape is split up into 4 little squares or rectangles, and this entire area here has got to be the same as what would happen if I did those 4 little pieces together. So if I work out the area of those 4 pieces, that should tell me the area of the whole shape. So if I've got the square here, it's got length x, width x, so the area of that is going to be x times x, which is x squared. If I look at this shape here, it's got length x, width 5, so the area of that shape is going to be 5 times x, which is 5x. This shape here, it's got length 3, width x, so we're doing 3 times x, which is 3x. And finally, for this little rectangle down the bottom, it's got length 3, width 5, so the area is going to be 3 times 5, which is 15. So if I add up all of these sections, that should tell me the area of the whole shape. So altogether, I've got x squared plus 3x plus 5x plus 15. So that's x squared. I can combine 3x and 5x to make 8x plus 15. So we know that that is the same as this. And that's a good way to think about what you're doing when you're expanding double brackets. Think about it as trying to find the area of something that's split up into a portion that you don't know and a portion that you do know. Okay. When we do the grid method for these, we don't tend to draw it to scale, so we tend to just draw it as 4 boxes. We don't mess around trying to make it look like this is 3 and this length is 5, because it wastes a lot of time. But the idea is still the same. So we'll have a look now at how you'd use the grid method to tackle another one of these problems. Okay, so we'll have a look now at what happens if we tackle another one of those sorts of problems. So we'll try x plus 4 times x plus 7. Okay, now I could faff around and draw myself something that looked nice and to scale, that looked like I'd got a rectangle that had got 4 and the 7 bit was bigger, but there's not really any point, especially when you're under exam constraints, so that will do. Okay, a box that has got equal size portions will do. We know that this bit split up into x and plus 4, and this bit split up into x and plus 7. Okay, I've put these in just to remind you that this plus is attached to this 4, so this is positive 4, and this plus is attached to this 7, so that's positive 7, because you'll need that later when we start to look at examples that have got negative numbers in. So again, x times x, the area of this bit, is going to be x squared, plus 4 times x, the area of that bit's going to be 4x. X times plus 7 is going to be plus 7x, and then plus 4 times plus 7 is going to be plus 28. And then combining them, we have x squared plus 4x plus 7x plus 28. And then we can combine our x terms together. So we get x squared plus 11x plus 28. And that's our question complete. We've expanded the brackets. Okay, here's a similar problem, expanding double brackets using the grid method, but this time we're going to include a nasty negative sign in, just to try and confuse things a little bit. The method is still exactly the same. We're still going to be using our grid, and we're still going to be splitting this up into x and positive 2, and then x, and then making sure that this minus stays with this 6, minus 6 there. X times x is going to give us x squared, plus 2 times x is going to give us plus 2x. Now we've got to start being careful. Minus 6 lots of x is minus 6x, plus 2 times minus 6 is going to be minus 12. So we're left with x squared plus 2x minus 6x minus 12, and we can combine our x terms. So we get x squared. Well, positive 2 take away 6, so we start at 2 in our number line and count down 6 is going to get us down to minus 4. It's going to be minus 4x minus 12. Looks nasty because of the negative sign, but actually it's quite straightforward as long as you remember your rules for multiplying and dividing negative numbers. Let's look now at expanding double brackets, and this time we'll look at a particularly nasty one. Okay, so what I've done here is this time I've got a 2 in front of my x here, and I've got a 3 in front of my x there. So my coefficient, my number in front of x, is a 2 here and a 3 here. Your process is still the same, that hasn't changed. So we're going to need a grid, and we split up in the same way, except that this time we split it up into 2x and plus 1, and then 3x and minus 2. Now we've got to be careful when we multiply these together, because 2 times 3 is 6, x times x is x squared, so we get 6x squared. 1 times 3x is going to be 3x. 2x times minus 2, well, 2 times 2 is 4, minus 2 times 2 is minus 4, and then we've got our x there. And then finally, positive 1 times negative 2 gives us negative 2. Combining them then, we've got 6x squared plus 3x minus 4x minus 2. So again, if we collect our x terms together, we've got plus 3 minus 4, which is just minus 1x. Now we don't like to write minus 1x, so we just write minus x minus 2. That's pretty much as nasty as they get, so if you can do those, you can pretty much say that you've mastered expanding double brackets.